Okay, so for the first question for optimization question 1, we get an observer stands at point P, 1 unit away, so he stands here, 1 unit away from the track, which is this. The one runner runs 3 times the length of the other, so I've split this into x and 2x. This 3x is what the one runners run, and x, which is a third of that, is what the other runners run. Now our job is to maximize theta, which is the angle between the two runners, and the hint they've given us is to maximize tan theta. So I've made this angle equal to alpha, and then you can tell that tan alpha is equal to x over 1. So then tan alpha equals x is your first equation. The second one, you can tell that tan alpha plus theta, this entire angle, is going to give you this entire length over 1. So that's going to be tan alpha plus theta is equal to 3x over 1, which is equal to 3x. So that's our second equation. Tan alpha plus plus theta can be written using trig rules as tan alpha plus tan theta over 1 minus tan alpha tan theta equals 3x. However, from our first equation, we understand that tan alpha is equal to x. So we fill that in place of tan alpha. So we have x plus tan theta over 1 minus x tan theta is equal to 3x. After that, we carry across the other side and multiply out. So we eventually land up with tan theta plus 3x squared. Tan theta is equal to 3x minus x. Then we can pull out tan theta and basically end up with tan theta is equal to 2x over 1 plus 3x squared. So then this is the equation we have to maximize. So finding the derivative of this equation is going to give you 2x multiplied by 6x minus 2 multiplied by the bottom over the bottom squared is equal to tan theta. Then you have to multiply all this out and make it equal to 0 because we're going to find the maximum. So after you've multiplied all this out, you get this. We move this across, which is obviously just going to, so we're just finding the derivative of the numerator. So we make the numerator equal to 0. Then we pull out 2 to make it easier. And then we eventually get 3x squared minus 1 equals 0. So x is going to be equal to square root a third. Now we fill square root a third back into our this equation in place of x. So we get square root a third plus tan theta over 1 minus square root a third tan theta equals 3 square root a third tan theta. We move that across, we multiply it all out, and we move it across again, and we eventually get 2 tan theta is equal to square root 3 minus square root 1 over 3. So tan theta is equal to square root 3 minus square root 1 over 3 over 2. And so if you simplify that, you get tan theta is equal to square root 3 over 3. Using your special triangles, you can tell that the theta is equal to pi over 6. And so that's going to be your maximum angle of theta between the two runners. That's it for question 1 of optimization.